Once again, I stress the fact that a utility is a business. The utility must make a profit in order to stay in business. It does this by charging for its product, electricity. A profit is earned by charging the customer slightly more for the electricity than the utility's cost to produce and deliver the electricity. The utility uses a power meter as the basic component of its cash register and billing system. Utilities are now replacing their aged installed base of old-fashioned electromechanical meters, such as this meter, which is about 50 years old and only recently taken out of service, with new, modern 21st century power meters, such as this one, manufactured in Mexico by a company called Landis Plus Gear. The new meters are often referred to as smart meters, and even President Obama has referred to the importance of smart meters as paid for from government grants.
But most of the projects that are receiving grants involve the installation of what are known as smart meters, devices that will have a direct benefit for consumers who want to save money on their electric bills. Now let me explain what's going on with these smart meters. Smart meters will allow you to actually monitor how much energy your family is using by the month, by the week, by the day, or even by the hour. So coupled with other technologies, this is going to help you manage your electricity use and your budget at the same time, allowing you to conserve electricity during times when prices are highest, like hot summer days. And all this information will help increase renewable energy generation, provide support for plug-in electric vehicles, and reduce the carbon pollution that causes climate change.
This improves accuracy and service for all utility customers. And this ensures maximum cost efficiency for the utility and reduces theft of power and other issues, which increases everybody's bills. Most new smart meters, paid for in part by the government stimulus funds or government grants, contain a home area network component. Engineers call this a HAN transceiver. HAN, H-A-N, meaning home area network. It is a device installed inside the meter which sends electronic data from the meter and from the utility company to devices inside the home. Today, the American meters use what is called a ZigBee HAN transceiver. From now on, I will simply call this the meter ZigBee. The in-home energy management system, or EMS 2020 as an example, must use the data coming from the meter ZigBee in order to work. However, when the meters are installed, the meter ZigBee is in the sleep mode. Only the utility company can wake it up and turn it on. Today, only a handful of meters around the country have their ZigBees turned on. In fact, less than 2,000 out of a total of 25 million meters with a ZigBee installed. Customers must ask, demand, that their utility turn on the meter ZigBee, and the customer must work with the utility on the utility's website to set the ZigBee up. There must be something inside the home which can communicate with the meter ZigBee in order to make it wake up in cooperation with the utility company. In other words, the customer must have a widget which the ZigBee can talk to when the utility company starts to enable it. Just like a cell phone with a SIM card, the homeowner's ZigBee widget has a unique digital address and registration number. Electronic protocol handshaking takes place when the utility begins to turn it on. Today, almost all utilities are ignoring the ZigBee device. Why? Because the utility is a business, and as such, it focuses on what it needs to do in order to deliver its product. Its product, of course, is electricity, and to get paid for what it delivers. In other words, the utility doesn't want to be bothered by potential problems associated with making the ZigBee work, and problems associated with what happens in the event it does not work. Secondly, the meter data management companies and related software vendors tell the utilities why bother. After all, they have massive amounts of data coming from each and every customer's meter, which can be regurgitated on the utility's customer website. Never mind the fact that this data is hours, if not days old, and it can't begin to help the customer manage usage in real-time terms. And consumers are targeted by anti-smart meter propaganda, which the utilities must fight. The utilities are also afraid that the ZigBee will add to that propaganda and make the smart meter backlash even worse. Why? Because of the misinformation people have about the smart meter. Example number 1, meters are a spying tool. Not true. All electrical circuits in a home are parallel circuits. An engineer or scientist expresses this as a mathematical set of formulas known as the power formula and the parallel resistance formula, expressed as followed. I equals E over R, and for parallel resistances, 1 over the reciprocal of 1 over Rx plus 1 over Ry plus 1 over Rz, etc. The smart meter is not that smart. It can't tell what loads are on and what loads are off. It can only tell the total load at any point in time. If you don't believe me, ask any electrician. And let's look at an example here, which I'll set up on my desk with a total of 650 watt light bulbs monitored by our EMS 2020 and associated meter. To make clear, let's look at an active demonstration of parallel electrical circuits. Let's take a closer look. To the left of the computer display, we see 3 150 watt light bulbs which are turned on. Notice to the right of the computer display, we have 3 additional bulbs that are off. As we zoom into the display, we see a total load of indicated 435 watts, representing the 3 bulbs that are burning. I now turn on the balance of the light bulbs, and I see a total indicated load of roughly 835 watts, which is close to 900 watts, which would be the theoretical amount for 650 watt light bulbs. The slight difference between the indicated 835 versus 900 relates to the line cord and what we refer to as losses in the wires between the metering point and the actual bulbs, the actual loads themselves. Now, I can walk over and I can turn bulbs on and off carefully because they are hot. We have left 2 bulbs illuminated. I zoom into our smart meter display and I see a total amount of power of 300 watts. I turn off these 2 bulbs. I zoom into our display, and we have a total power consumption of 0 watts. Why? Because no bulbs are illuminated. Now I'm going to turn on 2 bulbs. We now see our display indicating a load, roughly 300 watts, meaning 2 bulbs. But which 2 bulbs are turned on? I have no idea. The meter has no idea, and believe me, the utility receiving the data stream would have no idea which bulbs are turned on. How does the meter measure the load? Well, in our earlier meter series, Part 4A and Part 4B, where I took apart a Landis and Gyr power meter, I showed that inside the power meter we had a set of conductors, 2 of them, and a current coil, a current sensing coil. That exactly is what we are looking at here. One current sensing coil surrounding the wires connecting the AC power to the power distribution or power bus strip. The current transformer is connected to the EMS 2020 smart meter transmitter. This current transformer, in conjunction with this electronics, in fact comprises the internal circuitry of the modern smart meter. Power conductor, current sensing transformer, connectors to the utility, connectors to the home. Example number 2, radio waves are dangerous. They give headaches and they cause cancer. Well, absolutely not true. The smart meter uses radio communications to get its data to and from the utility and to and from stuff inside the home. True enough, but low-power radio waves are nothing more than the far effect of electromagnetism. And of course this occurs in nature. We are all exposed to what we call the galactic noise floor, or cosmic background level, of the entire electromagnetic spectrum from the day we're born until the day we die. The radio used to get the data to and from the meter to the utility is the same that's used in a 902 to 928 megahertz cordless telephone, which has been around since the mid-1980s. And the radio used to get the data inside the home is the 2.4 gigahertz ZigBee, which is like the radio used in wireless security systems, motion detectors, wireless computer keyboards, mice, and your hands-free cell phone between the earpiece and your smartphone. Harmless, harmless, harmless. Only the lawyers can make money from scaring people and making them think it's not harmless. And example number 3. Too much data is sent to the meter data management companies. In other words, the smart meter can send too much data to the utility too frequently. This can be partially true. However, it can be mitigated in the homeowner's mind by the fact that all of this data relates only to the total load at any time. Remember, the meter really isn't that smart. It can only determine total loads, not individual devices comprising the load. The meter cannot tell what appliances are on and off. Let's look at meter data from a Landis plus Gyr focus meter installed in our test rack as updated every 10 seconds. Let's talk for a minute by way of example about the issue of too much data being sent from each and every meter to the utility or to a meter data management company's data warehouse. In this instance, we have a Landis plus Gyr Focus smart meter which is connected to a PC which displays the amount of power virtually instantaneously. The meter is installed in our test rack, and currently we have set the calibrated load to 18 amperes. 18 amperes, roughly, at 120 volts, given the American system of 240, 120. The meter is being monitored by a PC. This is the PC with monitoring software connected to the Landis & Gyr focus meter in the test rack being exercised at 18 amperes at 120 volts. Let's look at the data streams coming from the meter. We turn on what we refer to as the EMS 2020 Executive Server, which again is a hardware and software program which actually looks at the data streams originating from the focus meter. What we are looking at, this 4-digit number, 2128, is 2,128 kilowatts, 2,132 kilowatts. It will update roughly every 10 seconds. 2,142 kilowatts. The very, very slight difference relates to the fluctuation of the line voltage. The next digit that we're looking at, the next number I should say, 63116, 63116, and to be followed again by 63116, relates to 63,116 kilowatt hours, which is the total amount of kilowatt hour use on this particular meter in the test fixture. The final number is a hex value, which is irrelevant for this conversation. Notice that this data is updated roughly every 10 seconds, but the fact of the matter is, internal to the meter, these numbers are being updated hundreds of times per second. It's simply a matter of computer programming, either within the meter or at the utility company or anywhere in between, which determines how often we display a specific number on the screen. We can transmit this data every 10 seconds. We can transmit it every 10 minutes. We could transmit it every 10 hours. Or we could transmit it once a month. Again, the only thing the utility company is truly concerned with is this value, which is the total number of kilowatt hours consumed per the billing period for a straight, non-tiered, non-time interval tariff. In the event of a complex rate tariff, such as a peak demand rate, a time of use rate, or even tier rates, all of the mathematics necessary to calculate those rates for an extended period of time, such as a 1-month billing cycle, can be done inside the meter. It's not necessary to send this amount of constantly updated periodic information to the utility or to a third-party meter data management company. Who needs all of this data? Well, from a practical standpoint, nobody. But on the other hand, companies whose business it is to manage it, store it, repackage it, and send it back to the customer a day later and sell it to marketing companies can make a fortune off of this data. Talk about fertile ground for telemarketers, acres and acres of diamonds to be mined and phone calls to be made. Our job is to get the widget to the people. Every utility customer must have one of these in-home energy widgets and get the cost data out of his or her power meter in order to better manage their power and save money, and more importantly, conserve power until we ultimately solve energy. Our job is to be the voice of the consumer through the Energy Site Consortium, helping the customer get his ZigBee turned on. Our job is to be the advocate of the utility by providing information and education to the customers on the safety and security of the smart meter. Our job is to be the principal interface between the customer and the utility during the meter ZigBee and widget ZigBee setup. Where did the name ZigBee come from? Well, it was named for the zig and zag movements bees make while working in their hives making honey. And most importantly, our job is to be the agent for change to solve energy. What does this mean? It means we must work to get utilities off of fossil fuels and onto something that can provide the amount of power needed to operate the utility power backbone grid. This backbone grid energy requirement is going to double and quadruple very soon as more and more electric cars are put on the road. Remember that a person will use close to 100 times more power in scientific energy units per month in their cars than in their homes. You don't believe me? Look at the size of your car engine. It's a safe bet that your car has at least a 125 horsepower engine. And since 1 horsepower equals 746 watts, you can do the math. That's 93,250 watts consumed by your car engine. Almost 4 times more energy than a typical American home utility service can deliver to your breaker box in terms of instantaneous power. Integrated over time, this still yields the 2 orders of magnitude or 100 times increase number. Needless to say, all the solar cells in the world and all the wind turbines in the world can only make a dent in terms of backbone grid energy. And what about the environment and greenhouse gas issues? It's almost a moot point. Why? Because the Earth is billions of years old, 4.6 billion years old, and we've only been polluting for the last 100 years or so. By 2050, virtually every coal and natural gas burning plant in the United States will be worn out, and the EPA, along with the environmental groups, will not let new ones be built. Or, if they are built, they certainly won't let them be turned on. What does this mean? It means we had better solve energy, or we had better outlaw having children worldwide, because by the time our grandchildren are our age, the Earth runs out of fossil fuels, and its fossil fuel plants are broken down regardless. Part of our energy site job is to bring this critical information to the public's attention and to be the party responsible to solve this issue. And solve it we will. The future of mankind depends on it. We plan to bring this to the American people, and in fact to the people of the world, to obtain their support and backing in conjunction with America's 1,500 electrical utility companies. In summary, millions and millions of smart meters are being deployed nationwide. These meters have a ZigBee unit inside them. Customers must demand that the ZigBee unit be turned on. We can help them by providing the proper forms and information to their utility company. We can also help them by providing the in-home ZigBee widget, which is the EMS or Energy Management System hardware interface. The anti-smart meter groups are providing inaccurate and misleading information to consumers. We can help utilities overcome that by providing education based on the facts. Our short-term mission is to convert utility ratepayers into customers. Our long-term mission is to serve as the people's partner to solve energy. How do we do this? Please take the time to watch my interview with the entertainer and singer Pat Boone posted on YouTube. Simply do a Google search on Tamarkin, Pat Boone, Fusion Energy Discussion. That video should be the topmost Google reference.